Welcome back, guys. So here is another series of Question Decoded. We have series 8, and as you can see, this question is from UI Post-UTME. Now, it said a man moves with a velocity of 20 meters per second. Okay, so we have our solution. The initial velocity being used by the man, which is our u, is equals to 20 meter per second on a rough horizontal road. When you hear the word rough, you know there's likelihood of there being a friction, okay, and covers a displacement of 50 meters. That is the distance which was covered. So S equals to what? To 50 meters. Okay, find the coefficient of what? To of dynamic friction. So we are looking for coefficient of dynamic friction, which is our mu. Forget I'm using u to denote it. Okay, which is equals to what? Is unknown. Okay, after it covers a displacement of 50 meters. So since it covers a displacement of 50 meters, that after that time, after covering that distance, the motor must have come to what? To a rest. You know, and when something comes to a rest, our final velocity equals to what? To 0. Moving on. Okay, find the coefficient of dynamic friction. We've talked about that between the tire and the water and the ground. So how do we solve what? How do we solve this question? The first thing you have to take note of is that when you when a car is moving and the car wanted to stop, the driver has to press the brake, and when the brake is working, the force that is that is stopping that car is the frictional force. That is, at that moment I can assume that my net force is equal to the frictional force. So you know my frictional force Fr equals to what? To Fr equals to mu r, or you can say mu m to mu mg, anyone you like, where r is your normal normal reaction. So instead of writing net force like this, I can write net force equals to Fr equals to mu m to mg. Okay, now we have something like this. Okay, what's the formula for net force? Net force is equals to ma. So I can assume my ma equals to mu m to mg. M will cancel m. That is my my a will now equals to mu g. Or you're making mu the subject. Mu equals to a over what? A over g. That is the formula we are going to be using. Mu equals to a over g. So what do? You look for the what? You look for the value of a. So now how do you find a? You can see all these things we have been given here. Now let us look for a. We have VSU. Okay, if we have VSU and we are looking for a, which formula can you use? We have V square. We have V square equals to U square. Okay, we have V square equals to U square. Because the motor is decelerating, the man is applying a brake. The deceleration is going to be negative, so minus 2as like this. So what do we have? V square. Though if you like, you can also put plus. It just indicates that your acceleration at the end of the day is going to be negative. So what's our V? 0. So we have 0 square equals to what's our U? We have 20 square plus 2 into bracket. We are looking for A, and our S is 50. Okay, if you 0 square equals to, we have 400 plus 100 100A. So making A the subject, we have minus 400 equals to 100A. So divided by 100 divided by 100. So our A, as you can see, is negative equals to minus 4 meters per second square. Okay, so now what's the next thing? We are now looking for our mu, which is the coefficient of friction. It is now equals to A, which is minus 4, but you don't need to put it there. You can see that all our option doesn't have a negative. So we are going to have 4 divided by what's acceleration due to gravity? 10. So we have divided by 10. Our mu equals to 0.4. Thank you very much.